let's do some simplifying. Talked about domain. Now let's talk about simplifying some of these rational expressions. So when we do some different problems with these rational expressions, I'm going to review back with the regular fraction problem, and then we'll kind of compare. So let's say 12 over 36. 12 over 36. A little better. So, I mean, normally we would just look at it and say, what do they have in common? Reduce by that. But I'm going to kind of go back to maybe possibly when you first learned fractions, how we would have broken this down. So if I think about how can I break down 12, well, 3 times 4, so I'm going to write 3, but then 4 can be broken down still to 2 times 2. 3 times 2 times 2, that's 12. So this is bringing it down to factors of, product of prime factors. So 12 broken down to all of its prime factors, product of prime factors would be 3 times 2 times 2. Or a different order. How about 36? Maybe this one I'll jot over to the side. A little technique you could do, break down to 6 times 6, 3 and 2, 3 and 2. So we've got 3 times 2 times 3 times 2. Again, the order doesn't matter. So what we would do, once it was all factored, notice I'm using this word factored. Factored means it's all multiplied together. So only once it's all multiplied together, then we can reduce things, cross them off. 3 and 3, those can cancel. Because it's just like we're doing 3 divided by 3, which is 1. 2 divided by 2, 1. Those are gone. So we'd be left with 2. Oh, well, that's done. 2 and 2. Down to just 1 over 3. Okay, which, I mean, back to the beginning, that's not really how we normally would do this at this point. Hopefully you kind of know, just looking at it, okay, I could reduce by maybe even just 6. Or if you realize it, you could reduce by 12 right away. 12 divided by 12 is 1. 36 divided by 12 is 3. But I just kind of want to emphasize that everything needs to be multiplied together, and then as long as it's the same exact thing, once on the top, once on the bottom, you can cancel it out if it's multiplied by the other things. Okay, so now let's throw in some x's. 4x squared minus 6x over 2x minus 3. Okay, so now, if you kind of look at this and you first think, oh, 4 and 2, I could reduce those. We can't do that yet. It would need to be something's multiplied. Like 4x squared, there's a minus sign here, plus this is x squared, this is x. It would need to be the exact same thing multiplied by something else. So first step with these is we first need to factor. First factor. So, looking at the top, what do they have in common? There's a 2 and an x that they have in common. So factor 2x out of 4x squared, I'm left with 2x minus, take 2x out of 6x, I'm left with 3. Go back, do a little check, 4x squared minus 6x. Bottom can't really do anything, but now we can see this is like 2 times, use some different color here, 2 times x times 2x minus 3. This is one full thing on the bottom, 2x minus 3. So since they're the exact same thing, the whole thing can cancel out. So we would be left with 2x over 1, so just 2x. Okay, so notice, the whole thing is multiplied by the other thing, so it needs to be full factor. Let's do one more. Okay, one more. How about example x minus 5 over x squared minus 25. Okay, so again, first step, factor. So on top, can't really do anything, but on the bottom, this is a difference of squares. See that number 25? That should be a little red flag. This breaks down to 5 squared, so this can be factored to x plus 5, x minus 5. So here, x minus 5, those can be canceled. Since there's nothing on top, I would denote it like we're left with 1. 1 over x plus 5. Just like back when we were left with 1/3. You have to put something there. So we would have a 1 on top.